Hi, everybody. Welcome back. So we're going to cover example 3 of section 6.1. So this says find the area of the region that is completely bounded by the two curves, f of x equals x cubed minus 5x plus 20, and g of x equals 4x plus 20. So if you notice in this example here, they didn't give us any vertical lines. So how do we figure out where to integrate from? Let me go ahead and write that out. What if they don't give us vertical lines? So the way to integrate, if we're not given vertical lines, is we need to know where they intersect at. Or I'll say where the functions intersect at. And what that means is we're going to get some x values. Okay, so first thing to do, for example, the 3 is graph it. We're going to get our top and bottom functions as well as the intersections. Okay, so let's go to Desmos and graph both of these functions. So here I will have y equals x cubed minus 5x plus 20. And I'll have y equals 4x plus 20. Okay, so let's go ahead and see where both of these functions intersect at. So to me, it looks like we are intersecting from -3 to 0. And we have one more above 3. So that's 3 different intersections we're going to be intersecting at. Notice here that from -3 to 0, the red function is on top. So that means x cubed minus 5x plus 20 is on top. And from 0 to 3, let me label the points as well. From 0 to 3, the blue function is on top. So 4x plus 20 is then on top. So we have what we're going to have here is 2 separate integrals going on. So if we come back to the notes, we will say here that intersect at x equals -3, 0, and 3. And we'll say that f of x equals x cubed minus 5x plus 20 is on top from x equals -3 to x equals 0. And that g of x equals 4x plus 20 is on top from x equals 0 to x equals 3. So we're going to have 2 integrals. So for our first integral, we're going to have from -3 to 0, f of x minus g of x dx plus the integral from 0 to 3, now g of x minus f of x d of x. So if we plug in our functions now, we should have the integral -3 to 0 x cubed minus 5x plus 20 minus 4x plus 20 dx plus the integral from 0 to 3. G of x is now on top, so it's switched. 4x plus 20 minus x cubed minus 5x plus 20 d of x. So I'll give you guys a moment to try out both of these integrals, same way we've been doing, and you can verify your answers in a second. Okay, welcome back. So hopefully for the first integral from -3 to 0, you should have gotten 20.25. And your second integral from 0 to 3, you should have also gotten 20.25. Okay, so double check your work and see if you can get that final answer if you didn't get that. But at the end of this problem, we're just going to add both of these areas together, and we end up with 40.5 as our area. Okay, so that one was definitely a more involved problem because we had two separate integrals, but it's still the same idea as always. We're top minus bottom and integrating over those intersections. Okay, so let's go ahead and try out another problem. Example 4. So find the area that is completely bounded by the two curves. F of x equals -x squared plus 8x plus 70, and g of x equals x squared plus 10x plus 30. So like before, we're not given intersections or vertical lines to integrate over, so we got to graph it and get our top minus bottom and our intersections. Okay, so let's go ahead and Desmos to graph this thing. So let me exit out all of these and graph the function. So y equals -x squared plus 8x plus 70, and y equals just x squared plus 10x plus 30. Okay, great. So let me zoom out a bit. So it looks like here we only have really two intersections. Down here, let me go ahead and label that. It's at -5 and 4. Okay, so only one integral this time. And it looks like the red is on top from -5 to 4, and red is -x squared plus 8x plus 70, and that is our f of x. So f of x is on top from -5 to 4. Okay, so f of x is our top function. So let's go back to the notes, and we'll say f of x equals -x squared plus 8x plus 70 is top function, and we intersect at x equals -5 and x equals 4. So our integral is going to look like -5 to 4 f of x minus g of x dx. And so if we plug in these functions, we will get -5 going to 4, -x squared plus 8x plus 70 minus x squared plus 10x plus 30 dx. Okay, so if I distribute in the negative, what this ends up becoming is negative 5 to 4, negative x squared plus 8x plus 70 minus x squared minus 10x minus 30 dx. Let me put some parentheses around this and combine some like terms. And what we end up with is negative 2x squared minus 2x plus 40 dx. So now let's go ahead and integrate. So we get negative 2x cubed over 3 minus 2x squared over 2 plus 40x going from negative 5 to 4. Okay, almost done. Let's go ahead and set up our brackets. I'm going to come over to the left here. So this would be negative 2 times 4 cubed over 3 minus 2 times 4 squared over 2 plus 40 times 4 minus negative 2 times negative 5 cubed over 3 minus 2 times negative 5 squared over 2 plus 40 times negative 5. And what we end up with is 101.33 minus negative 141.67. And two negatives make a positive, so 101.33 plus 141.67. And our final answer would be 243. Okay, so that's it. That's 6.1. That's the last content for this class. So the last bit of content was area between two curves. I hope you enjoyed this course and enjoyed listening to me lecture this material. But that's it for this course, and good luck with everything else. Thank you. Bye.